Hello Math 2 and welcome to your supplement piecewise functions notes. All right, so we have touched on piecewise functions before. For this problem, they're asking us to come up with the equation of the given piecewise function. So one thing I want to point out is I want you to notice that there is 3 different parts to this piecewise function. All right, you can tell that there's clearly 3 different portions to this, and because of that, we're going to end up with 3 different equations. All right, so let's go ahead. I'm going to actually pick some better colors. We'll do this first part first. All right, this part I just did in green here. So we have to come up with the equation of this line. All right, and we did do some practice with coming up with the equation of a line. So what we can do is grab 2 points from this line. I'm going to pick this point and this point. So we end up with -3, 4. And we end up with 1, 2, 3, 4, 5, 6, 7, 8, 9. We get -9, 1, 2, 3, 4, 5, -5. All right. So we need to come up with the equation of this line using these 2 points. So hopefully by now, you know, first thing we got to do is find the slope. So we're going to do 4 minus -5 and -3 minus -9. How did I come up with this equation? I used our slope formula, which is y2 minus y1 all over x2 minus x1. And I can label these x1, y1, x2, y2. All right. And we end up with 9 over 6, which we can change to 3 over 2. All right, so that gives you the slope of that equation. So now we've got to plug it into our point slope form, which is y equals m times x minus x1 plus y1. All right, so we can go ahead and plug in our slope and our point here, which we can use this -9 and -5. Oops. You just pick one point to plug in here. So we could do +9 minus 5. All right. And that is going to be my equation for that first function. Now, I'm not done, though, in terms of that equation. I came up with the equation, but now I need to say, well, what x values is that good for? All right, so look at where this equation begins. It starts here at x equals -9. And it ends at x equals -3. So what we can do is we can say, all right, this is going to be good for x values greater than or equal to -9. And good for x values less than -3. All right, so that is our first equation there. So I'm going to go ahead and erase my stuff so you guys can kind of follow along a little bit easier. All right, so we've got our first equation. So now let's go ahead and come up with our second equation. Let's use blue. So we've got this guy here. So again, let's go ahead and come up with 2 good points. Actually, you know what we're going to do? This question's a little bit easier because it goes through the x-intercept. All right? So because it goes through the it goes through the y-intercept. Duh. Right? This is the y-axis, and we can tell it goes through the y-axis. So we can actually go and put it straight into y equals mx plus b. All right? The y-intercept here is 1. And then all we need to do is come up with the slope. So let's pick 2 points. We can use 0, 1. And how about let's use, we'll use this point here. We've got 3, -2. So let's go ahead and find the slope between these 2 points. So we're going to use y2 minus y1 all over x2 minus x1. And let's go ahead and plug these in. We'll say x1, y1, x2, y2. So we get we get -2 minus 1 all over 3 minus 0. So I'm going to end up with negative 3 over 3, which is going to give us a slope of negative 1. So now for this equation, we know our slope, which is this m part, and we know our y-intercept, which is this b part. So we could come up with our equation of a line. It's going to be y equals our m, which is negative 1, times x, and then plus our b, which is 1. All right. Let's say you didn't want to use the y equals mx plus b. You could go and do it just like we did the first equation and use this equation, the point slope. There's nothing wrong with that. All right, let's see. We're running out of space here. All right, we got one more equation here. We'll do this guy in red. Oh, actually, sorry, we're not done with the blue guy. We got to give him his x values, right? So we'll say this guy, we can see he starts at negative 3. So we will do a closed bracket there at negative 3. Now, here's the thing. Because this is continuous and there's no open circles and closed circles, it really doesn't matter which one gets the closed at negative 3. You can't tell who's closed at negative 3. The thing is, they both can't be closed and they both can't be open. So you just have to pick one to be closed and pick one to be open. I wish there was a more straightforward answer, but in this case, we don't have one. So you just kind of have to pick. And then, we end at x equals 3. So this is going to be good for values less than 3. Now let's go ahead. We will do our red line. So we're going to go ahead and pick 2 points so that we can come up with the slope, and then we're going to plug it into point slope, just like we did the first one. All right. So go ahead. We have this point here. We're going to do 1, 2, so we got 3, negative 2. And we've got 1, 2, 3, 4, 5, 6, comma 1, 2, 3, 4, 5, 6, 7. 7. Okay, so what I want you to do is go ahead and calculate the slope between these 2 points. You're going to use the equation. y2 minus y1 all over x2 minus x1. And you're going to use these 2 points, 6, 7, and 3, negative 2. So when you calculate the slope, you could label these. We'll say x1, y1, x2, y2. So we get negative 2 minus 7 all over 3 minus 6. We get negative 9 over negative 3, which is going to give us a positive 3 slope. All right, and that appears to check out there. So we've got our slope. Now we're going to plug it into point slope form. Point slope form is that. So we're going to plug in our slope into m, and then we can pick a point to plug in for x1 and y1. We'll just use the x1 and y1 we were given. So we'll say y equals 3 times x minus 6 plus 7. Notice how the sign of the 6 changes, right? Because when you plug in for x, the sign changes. When you plug in for y, the sign stays the same. So this is, our equation for the last part. Now, these are all, I'm writing these equations in point slope form. You could get these into y equals mx plus b if you wanted. It really does not matter. So yeah. And then let's go ahead and figure out which x values these are good for. So you can see this starts at 3 and ends at an x value of 6, right? It goes from 3 to 6. And we'll say equal to 6 and equal to 3. So the reason I made it equal, less than or equal to 3, was because I left this one open. So one of them needed to be closed. And then I closed it on the 6 because there is a closed circle there and there's no other function to kind of represent it. All right. So now it says list the domain for the function. Okay, so first off, let's talk about what the domain is. The domain is the x values. So what is kind of your range of x values, right? What x values did we plug in here? So we started plugging in x values at -9, and we stopped plugging in x values at 6, right? So we plugged in all of these x values. So our domain here is going to be, there's two ways to write the domain. So I'm going to write them both ways so you can kind of get familiar with both notations. So one way would be that x is greater than or equal to -9. X is less than or equal to 6. That's showing that you have x values in between 9 and 6. Then another way to show this is using brackets. So these guys, when it's equal to, you're going to use brackets instead of parentheses. So you're going to do bracket -9 to 6. That is one way to also show it. All right. So those are two ways to show the domain. Now we've got the range. So the range is the y value. So what we're going to do is let's actually just show the highest part of the graph and the lowest part of the graph. All right. The highest part of the graph is going to be at y equals 7, right? We go 1, 2, 3, 4, 5, 6, 7. So that's our highest part of the graph. And our lowest part of the graph is 1, 2, 3, 4, 5, -5. All right. So the range is going to be y values less than or equal to 7, greater than or equal to -5. And then, of course, you could write that in bracket notation. So we'd have -5 to 7. All right. Now it says, where is the function increasing? I like this question. So increasing is where the function's going up. If you're talking about lines specifically, it's just going to be where you have a positive slope. So the function is going to be increasing with this guy and with this guy. Do you see how they're both going up? The reason the middle guy is not increasing is because he's going down. All right. So the function is going to be increasing from, and we'll do the same again where we do bracket notation. We could say x values less than -3, greater than -9. So that represents these x values. All right. And it's going to be increasing from x values of +3 to 6. All right. Now, if you wanted to write this in the interval notation, you would write this as -9 to 3 and 3 to 6. So notice how I used brackets before when these were closed. With increasing and decreasing, you leave them. You don't do the equal to symbols. And the reason for that is because at this actual point right here, it isn't increasing or decreasing. It's kind of changing. It's changing, increasing to decreasing. So you can't say that it's increasing at that point, so you leave the brackets open. All right. Then it says, where is the function decreasing? All right. So if we look, the function's going to be decreasing on that blue line. So that's going to be between x values of -3 and 3. So we'll do -3 greater than x less than 3. And then if we wanted to do interval notation, we could say 3 to 3. All right. Next, it says find f of 0. So all they're asking you to do here is they're saying, well, when your input is 0, what is your output? So let's look. Input 0, your output is 1. All right. So that is going to be 1. Now it says f of -7. So let's go to -7. You input -7. Your output is -2. All right. Now let's look at f of 1. When your input is 1, what is your output? Look at the graph. When your input is 1, what is your output? So your output should be 0. Next, this last part, it says find f of x equals 1. So this is the opposite. Before, all right, they gave you the x value and said, what's the y value? For this problem, they're giving you the y value. They're saying, what's the x value? Okay, so if we look, when your y value is 1, what is your output? We actually have several outputs here. Or I'm sorry, we have several inputs, right? Several inputs that will give you an output of 1. So you have 1, 2, 3, 4, 5. So you have negative 5. You have x equals 0. And you have x equals 1, 2, 3, 4. All right. All right, so for this one, it says, given a continuous piecewise function that represents miles driven over numbers of hours. So it says, find f of 4. So let's look. They want us to find f of 4, and we have to decide which equation to use. I want you to think. Oops, 3, 4. I want you to think, are we going to use equation 1, 2, 3, or 4 for f of 4? Look at the intervals. Which equation are we going to use? So we're actually going to end up using, I guess I shouldn't erase those. We're going to end up using equation 3. All right, we're going to use this equation here. Why do we use this? Because 4 goes in between 3 and 6. So let's go ahead and plug a 4 in. So we're going to do 60 times 4 minus 3 plus 150. So that's going to give us 60 times 1 plus 150. Which will end up giving us 210. All right. So that would be our output there. All right. We don't have to worry about this because we're not going to make them continuous. So don't worry about C. So now it says, which interval has the fastest rate of change? What is the rate of change? So we've talked about rate of change. Rate of change is slope. All right. So we could go ahead. Which one has the fastest rate of change? Well, that's going to be the fastest slope. So actually, let's keep this. Which one appears to have the fastest rate of change? Look at the slope of each of these. Does equation 1, 2, 3, or 4 have the fastest rate of change? So that's going to be equation 3. All right. So that's going to be the, which interval? So equation 3 has that. So the interval 3 less, or, oops, x less than or equal to 6. That's going to be the interval with the fastest rate of change, and the rate of change is 60. All right. Because all of these equations are in the form y equals m times x minus x1 plus y1. So this right here would be your slope. All right. When you think traffic was the heaviest, so looking here, think about, right, rate of change is going to be how fast they're going, right? So when is traffic the heaviest? Well, that's going to be when they're moving the slowest. So look at these. Which equation do you think represents the slowest traffic? All right, that'd be when traffic is heavy. So that is going to be equation 4. And the reason for that is it has the smallest slope. Or I guess actually we'll even just say smallest rate of change. All right. And how many hours was the trip? All right. So the trip started at 0 hours and it went to 7 hours. So it was 7 hours long. All right.